The James Webb Space Telescope, the crown jewel of modern astronomy, has recently accomplished one of its most remarkable feats, capturing an unprecedented and crystal-clear image of Proxima Centauri b, an exoplanet orbiting the closest star to our solar system. This breakthrough represents not only a technological triumph but also a profound moment of reflection for humanity as we continue to gaze outward in search of life beyond Earth. In the vast, star-strewn fabric of the cosmos, this tiny rocky world stands out as one of the most tantalizing places where life might exist. Proxima Centauri b, or simply Proxima b, resides just 4.2 light-years from Earth, orbiting the red dwarf star Proxima Centauri. As the closest known exoplanet to our solar system, Proxima b has long intrigued astronomers, but until recently our view of it remained frustratingly obscured, more mystery than clarity. The advent of the James Webb Space Telescope has changed all that. Thanks to its exceptional infrared sensitivity and precision, astronomers can now examine Proxima b's environment more deeply than ever before. The recent image of this enigmatic world, captured through a combination of infrared light and advanced data processing, marks a pivotal moment in exoplanetary science. What makes Proxima b so captivating is its location within its star's habitable zone, a region where temperatures might allow for liquid water to exist. On Earth, water is the foundation of life. If it exists on Proxima b, it could mean that the conditions are suitable for life to emerge, or perhaps even to thrive. This simple, tantalizing possibility has captivated scientists and space enthusiasts alike. Could there be life just a few light-years away, hidden beneath the clouds of a distant world? To discover Proxima b in the first place, astronomers employed the radial velocity method, also known as the wobble method. This technique detects the subtle shifts in a star's motion caused by the gravitational pull of an orbiting planet. It is somewhat like watching a candle flicker from across a field and inferring that someone is walking nearby, casting brief shadows. The level of precision required is astounding, but it worked. Proxima b was revealed in 2016, but only now, with the James Webb Space Telescope, are we beginning to learn what it truly looks like. Unlike Earth, Proxima b is extremely close to its star, about 1/10 the distance that separates Earth from the Sun. This proximity creates unique and extreme environmental conditions. The planet completes a full orbit, or year, in just 11.2 Earth days. One side of the planet is believed to be tidally locked, meaning it always faces the star in perpetual daylight, while the other side remains shrouded in darkness. The result is a planet of eternal contrast, blazing heat on one side and freezing cold on the other. These extreme conditions might seem inhospitable at first glance, but scientists are not quick to dismiss Proxima b's potential. The key lies in its atmosphere, or the possibility of one. If Proxima b has an atmosphere capable of redistributing heat, much like Earth's weather systems, then conditions across the planet might be more temperate than the stark daylight divide suggests. However, the picture becomes more complicated when considering the nature of its parent star. Proxima Centauri is a red dwarf, and like many of its kind, it is a flare star. This means it frequently emits powerful bursts of radiation and stellar winds, which could wreak havoc on a nearby planet's atmosphere. If Proxima b lacks a magnetic field strong enough to shield itself, any atmosphere it once had could be stripped away over time, leaving it barren and lifeless. Yet, despite this harsh possibility, the search continues. The James Webb Space Telescope plays an essential role in that search. Since its launch in December 2021, the James Webb Space Telescope has become our most powerful observational tool in space. Its ability to detect faint heat signatures and analyze the composition of distant atmospheres allows it to look for telltale signs of life, particularly the presence of water, oxygen, carbon dioxide, and methane. For Proxima b, water is the primary target. If the James Webb Space Telescope can find evidence of water vapor or liquid water on its surface, it would be a groundbreaking discovery with implications far beyond astronomy. Renowned Harvard physicist Dr. Michael Kirk explains that detecting water involves analyzing the infrared light reflected or emitted by the planet. The James Webb Space Telescope can observe in infrared wavelengths that are invisible to the human eye, enabling it to detect even faint molecular signatures. These data are then compared against known spectroscopic fingerprints of water, oxygen, or other elements to build a picture of what is truly occurring out there. And the implications are staggering. If Proxima b does have water, whether as surface oceans, underground reservoirs, or even frozen glaciers, it dramatically increases the chance that some form of life could exist there. Life does not necessarily mean intelligent beings building spacecraft or sending signals into the void. Even microbial life, simple, single-celled organisms, would be one of the most significant discoveries in human history. It would mean we are not alone, not unique, and not the only expression of nature's creative power. However, even if Proxima b has water, that does not mean it is Earth 2.0. Some scientists warn that the planet could be more like Venus than our home world. Ed Turner, an astrophysicist at Princeton University, cautions that Proxima b might possess a dense, toxic atmosphere with crushing surface pressure and temperatures hot enough to melt lead. Venus, after all, lies within the Sun's habitable zone, yet its surface is one of the most hellish environments in the solar system. Could Proxima b be a similar mirage, appealing from afar but utterly inhospitable? While we can only speculate for now, advances in space science are progressing rapidly. There are already ideas for how we might one day reach Proxima b. Current space probes like Voyager would take over 70,000 years to get there, but theoretical projects like Breakthrough Starshot aim to develop laser-propelled microprobes that could travel at 20% the speed of light, cutting that travel time down to just over 20 years. These missions are still in the early conceptual stages, but they reflect our growing ambition to visit, not just observe, our celestial neighbors. Proxima b is far from alone in the gallery of exoplanets. We have discovered thousands of exoplanets to date, ranging from gas giants larger than Jupiter to rocky super-Earths and mysterious Neptunian worlds. Some orbit close to their stars, experiencing extreme heat. Others drift in the frigid outer regions of their systems. This diversity has shattered our previous assumptions about what a planetary system should look like. It turns out our solar system is just one configuration in a cosmic kaleidoscope. Telescopes such as Kepler and TESS have contributed to this exoplanet boom using the transit method, watching for the dimming of a star's light as a planet passes in front of it. Now, with the James Webb Space Telescope, we are no longer limited to spotting exoplanets. We are beginning to study their atmospheres and climates in unprecedented detail. One of the telescope's most thrilling achievements so far has been the detection of carbon dioxide in the atmosphere of an exoplanet located 700 light-years away. This kind of detection was once a dream. Now it is a reality. NASA's former administrator, Charles Bolden, called this the beginning of a new era. It is difficult to argue with that. For the first time, we are not just mapping stars or admiring galaxies, we are investigating the chemistry of worlds light-years away. We are looking for the ingredients of life itself. And with Proxima b, that quest feels personal. It is not some hypothetical Earth analog in a far-off corner of the galaxy. It is right next door. The discovery of Proxima b and the continued exploration of its secrets represent a new frontier, not only for science but for humanity's own sense of purpose in the universe. This small exoplanet has already inspired new generations of scientists, engineers, and dreamers. It reminds us that the universe is vast, mysterious, and full of potential. Each new discovery is a step closer to understanding where we came from, what lies beyond, and what it means to be alive in such a sprawling, spectacular cosmos. As the James Webb Space Telescope continues to survey the skies, we await each new data release with eager anticipation. What will we find next? A second Earth? A planet covered in oceans? An alien biosignature that confirms we are not alone? The questions are many. The answers are few for now. But Proxima b has opened the door. The journey has begun. And the cosmos in all its silent grandeur is waiting.